In this video, we are going to discuss finding concavity of your graph and points of inflection using your graphing calculator. To do that in the calculator, we are going to go ahead and get our second derivative the same way we got our first derivative, except now, so you're just going to say take the derivative of our y2 line, since that's the line where your first derivative was taken. And so I'm going to go ahead and turn that on. There we go. So now also notice I have turned my calculator up on this to be operating at 400 times, or not 400 times, 4 times the speed of a regular graphing calculator. So when I hit graph, it'll graph significantly faster than yours. So what we're going to notice here is we have potential. So when we're talking about concavity and inflection points, how we find inflection points is where the second derivative, where the second derivative is equal to 0. So we have potential that we could have something happening right here, right around 0, where x is 0. And then it looks like we also have potential where this graph disappears onto the axis on both directions. We may have some things there. So let's explore this in stages. Let's first go ahead and see if we shrink our y's down really tight. Let's see what we see. So here we go. So for our y values, we'll leave our x values alone. And let's just take our y values to be from negative 0.1 to positive 0.1. And when we hit graph, hopefully we'll see something. Oh, there we go. We have a couple places where our second derivative is equal to 0. But remember, we still might have something hiding here on the x-axis. One trick to see if there is something hiding is you can always go into your graphing, I didn't go to the right place, go to your graphing area, so notice it's format in the blue writing, and I can go ahead and turn my axes off. So now when I do that, I can kind of see, we knew my axis is around here somewhere, and that's where it popped up. See, that wasn't my axis there, that was actually the graphing. So we do have something there at 0, and it's just being hidden by the axes. So I'm going to go ahead and turn my graph back on, my axis back on, make it easier to read. But at least now I know I need to do some extra exploring because we definitely have something happening here in the graph. So for now, with this screen, let's go ahead and just get this 0 and this 0 and go ahead and we are going to make another number line, but this one for the second derivative. And let's go ahead and start plotting these things. So we're going to go second, calculate, we want a 0, and I'm going to move my cursor somewhere to the left-hand side of the lower bound there, the lower 0, somewhere to the right-hand side. We go ahead and hit enter, and we are getting a 0 of negative 2.453. 2.45 should be sufficient. Okay. Now, don't forget though that we do need to keep in mind for finding our inflection points, this asymptote is still going to be here, so we got to keep that in mind. Okay, so then let's go ahead and find our other 0 by moving the cursor to the right. There we go, and we'll get to the other side of it. And voila. So this 0 is at 2.48. Okay, so far so good. It looks like we're filling out our second derivative table here pretty nicely, but let's explore in here. Let's get a really tight window around our x-axes. So if we go, let's say from -1 up to +1, let's see what we see. There is something right there, but what I'm seeing here, again, still something might be hiding on these axes. But if I go ahead and try to find this 0, you're going to see we're going to have a hard time. Yep, see, there is something right there. There's another one right there. So we're going to have a hard time because my y values are too small for this one. You can see how vertical this line looks. So let's go ahead and change our y values to make them bigger now. So this is going to be one of those rare cases where we're going to go make our y values large So that way I have more room to work with. Still narrowed in on this. See, there you go. So you can see we have the one x-intercept right there coming through, and then another x-intercept right there coming through. And that's where it was obvious. We could see we had an x-intercept. That's what the nice thing about narrowing our y values was, it just kind of made it very obvious in the screen. But it also made it so we couldn't do the 0 in the calculator because we didn't have enough space to go to the left and to the right of our 0. So we had to move our y's back out. And then now you can see this one, we did have one hiding right in here. So let's go ahead and get these zeros. So move to the left, move to the right, and we have a 0 at x equaling 2.669 e to the negative 6. And if you remember, e to the negative 6 means we're shifting our decimal places 6 places to the left. So really truthfully what we're seeing is we have one at 0. It's just the calculator's version of rounding error. So we have a second derivative equal to 0 at 0. The x value is 0. And let's get the other one. See if we can get it come back down. There we go. And there we are. And we have another one at 0.205-ish. So you can see here how we're able to hide these things was just by stacking them on top of each other, getting them so close together that it's very difficult to see. But with the calculator's help and by being a little creative by knowing we need to look close to our axes, and we can even turn our axes off, it makes it so we can see these things. So now we've gotten all of our second derivatives. So now let's go ahead and go to our table, and we'll test some values here and see where we have positive values and negative values. So we'll test something outside of negative 2.45. So negative 3 gave us a negative concavity. Something between negative 2 and negative 0.26. So negative 2 would be a good choice. That was a positive. So now I need something between negative 0.26 and 0. So how about negative 0.1? And that's another negative. Now I need something between 0 and 0.2. So how about positive 0.1? And that's a positive right there. Now something between 0.2 and 2, so if we did a 1, that'd be a negative. And last but not least, something outside of 2, so if we try 3, that would be a positive. So there we go. So now we are ready to talk about where our graph is concave up and concave down. Oops, let me get rid of these. And then we are also ready to fill in our inflection points. So let's just start with concave up and concave down. Concave up just means that you had a positive second derivative, which means your graph is going to have something that looks like this. Something that's facing, a cup that's facing up, or a smiley face, or however you want to discuss it. So we're going to go ahead and look for anywhere we had positive concavity, and that will be our list of, in our list. So we go from negative 2.45 up to negative 0.26, union 0 to 0.205, union, and then 2.48 up until infinity. And then similarly for concave down, we'll go ahead and fill those in, just looking for our negative regions. So that would go from negative infinity up until negative 2.45, and negative 0.26 up until 0, and finally 0.205 up until 2.48. Fantastic. And the last piece here was filling in our inflection points. So an inflection point means it's somewhere where your second derivative is equal to 0 and you had a concavity change going from negative to positive or from positive to negative. So we actually have several inflection points. We're going to have one here at negative 2.45 because we have the concavity change. even though you have the concavity change here, this is not an inflection point because it's an asymptote. So we do have an inflection point at 0, we do have an inflection point at 2.05, and we do have an inflection point at 2.48. So to get those inflection points though, we need to go back into our calculator, and these values, you have to remember, are not your y values. These are your concavities. So they're your accelerations or your second derivatives. So we want to go back and turn on our first, or y1, and go into our table. And the new values we're going to type in are all these inflection points we just highlighted. So negative 2.45, 0, 0.205, and 2.48. So now we can go ahead and fill in our list for inflection points and say we have, oops, let me get my pen back. There we go. That did not work. Let's try that one more time. I have a inflection point at negative 2.45, comma, negative 0.0085. Then I have a second inflection point at 0, comma, negative 1. Then I have a third inflection point at 0.205, comma, negative 0.6182. And finally, we have a final inflection point at 2.48, comma, 0.00839. Whew. Man, this has been a busy graph. So you can see we have 4 inflection points, lots of places of, lots of concavity changes, but nonetheless, we have used our calculator to help us get through this and finding things that would have been extremely difficult to see and very fun numbers if you weren't kind of being creative with your windows and how you look. Okay, best of luck.